I have a question for you. Suppose you have differential equation and you want to know if it's linear, if y is dependent, or if x is dependent variable. Let us take a look at this question. Determine if the following ODE is linear in y, in x. So the given equation is y squared minus 1 times dx plus x times dy equal to 0. So a differential equation is given to us, but we don't know if y is a function of x or if x is a function of y. We want to investigate these two cases separately. Let us recall that. If y is a function of x, then the nth order differential equation is written this way: f of x, y, y prime, and the rest of the derivatives. And suppose you have the nth order differential equation, so we are including y with order n. And we know that it's linear if we have the following: a n x, the nth derivative of y, plus the rest of the terms, a1x y prime plus a sub 0x y equals to g of x. But in the case that x is a function of y, x is equal to g of y, then we have a relation between x and y and the derivatives of x. Well, it's going to be linear if this relation g of, well, here you have y, x, x prime, the second derivative of x, and suppose this is the nth order differential equation, it can be written this way: a sub n of y, well, the derivatives, the nth derivatives of x, plus a sub n minus 1, plus the rest of the terms, the middle terms, plus a sub 1 y, the first derivative of x, plus a sub 0 y times x equals to, for example, a function like h of y. Very well. So suppose you want to write this differential equation in y. What's the meaning of that? It means that y is a function of x. To write this equation in y, we divide by dx. Why is that? We want to create dy over dx, the derivatives of y. So if we divide this equation by dx, we're going to end up having y squared minus 1 plus x dy over dx equal to 0. Or if you write it the way that we wrote a differential equation in general form, you're going to have x y prime plus y squared minus 1 equal to 0. Well, what do we see here? X times y prime. So far, so good. We don't have any problem here. There is no red flag. It follows the definition of a linear differential equation. However, this function is y squared. It must be in terms of x. So because of this, y squared minus 1, it is not linear in y. Okay. Now, what if you write it in x? It means that x is a function of y. Let's see what's happening here. to write this equation. We're talking about the original equation. This equation in x, we divide by dy. Remember that you're trying to create dx over dy, the derivatives of x. So what do we have? We have y squared minus 1 dx divided by dy plus x divided by dy, which is 1, and 0 divided by dy, which is just 0. Or if we rewrite this as a relation between the expressions in y and the derivatives of x, we're going to have y squared minus 1 times the first derivative of x plus x equal to 0. So what do we have here? We have an expression in y multiplied by the derivative of x, which is fine. There is no red flag here. And we have plus 1 times x, 1, a constant, times x, which satisfies the linearity of differential equation in x. So this is linear in x. So please note that we have to be careful. If we are writing a differential equation in y or in x, it gives us different properties, different characteristics. It might be linear or not.